So this is an Xbox One S board. I bought it for hopefully to turn it around. The original problem was that it doesn't turn on at all. And when I did the check here, it had a short, and this is the main input from the power supply. So when I did some tests, I found that the MOSFET that goes here was shorted, and it's an N-channel MOSFET, meaning that it's negative side. So I pulled it off, and then I borrowed the retimer IC from this board for a beautiful Minecraft edition Xbox One S 1 terabyte that's for sale. So ask me about that. I have this board here. This is also an Xbox One S. It has a potential short to either the APU or the South Bridge chip, which can be a major problem. It could possibly be not fixable. But I believe it has a good retimer IC, and I know that all these MOSFETs are good. So I'm going to borrow the MOSFET from here and the retimer IC from here to put on the other board. And if we get it going, that'd be awesome, because it'll be a gift for my boy. So now I'm going to pull off the power daughter board, get it out of the way. This is the Wi-Fi adapter, get it out of the way. And we're going to go ahead and power on the exhaust fan and the soldering iron station. Let this bad boy heat up to a little over 800 degrees with the airflow of about 30%. So I'm going to apply some flux. This stuff really is a necessity with soldering, especially when you're doing micro soldering like this. Helps the flow of solder. I've tried to solder without it, and it does not work very good. So what we're going to do is we're going to heat up this chip so that I can pull it off the board, keeping in mind the placement of the number 1 pin, which you can't see it here, but there's a little dot on the chip, and then there's a dot on the board that shows the number 1. So here's a view of the chip on this monitor that shows all this looks like under a microscope compared to what it looks like without a microscope. You can see the flux is starting to spread a little bit. Things are starting to heat up. We got a little bit of smoke going on, but that's why we have our exhaust vent. Here's the location of the number 1 pin I had mentioned earlier. There's a dot right there and then a dot right there. So let's get this bad boy heated up, and once we do, we can pull it off. So we got it pretty hot. We got our tweezers. Let's see if it's going to come off easy. Nope, it's not ready yet. See where we're at. We got to be real careful. I learned from my mistakes of heating things up not enough, and then you rip pads off, and that's a real pain in the freaking boot. You gotta do trace repair with wire that's like freaking soldering hair from someone's head. This guy is not ready yet, so it's got to be a little more patient. Continue to apply heat, being very careful not to knock off any of these little tiny resistors or capacitors here, because they are a real pain in the boot to freaking find and put back on sometimes. So that's why we're at a low airflow, because they weigh so little that what ends up happening is the air from this guy will actually blow them away, and then you got to find them. Okay, looks like this guy's ready to come off. He was. Let me get a little bit more heat. There it goes. So now we've got the retimer IC removed. We can go ahead and set him upside down for now, because what ends up happening is sometimes it's still hot, so it'll kind of solder itself, or it'll bond itself to the board right here, burning up the solder mask, and then it's difficult to pull off. Next thing we're going to do is we're going to pull off this MOSFET applying some flux. I need to put it under the microscope though, because I need to keep an eye on where the gate is at. Probably just pull this one off right here. So we'll go ahead and apply some flux. Without flux, it's a mess. Let's put it that way. The flux is cold, so it doesn't really want to come out very good. So here we go. Here's our flux on both sides. Kind of heating this guy up, as just holding the heat as we're applying flux. So, still applying some heat to this guy. It's gonna take a minute. As you see here, this is another MOSFET. They're from what I understand, they're in the same circuit. This is that dot that indicates pin number 1. This is on this one in particular. If you notice the circuit here, this is your gate, which tells this MOSFET to turn on, and this is the microcontroller. This is a controlling IC. Sometimes those go bad as well, and then you have the. So this is, they call it the high side MOSFET, and then this is the low side. So one controls higher voltage than the other, or higher current. I'm not really 100% sure, but they are in-channel MOSFETs, so they control ground. So it looks like we got this guy hot enough. Now we can pull him off the board. Being very careful not to rip any pads. Go ahead and set him upside down. So much for my idea of putting them upside down. They still get hot and kind of burn themselves to the solder mask on the board, so I got to sit here and kind of wiggle it a little bit, and it will come off. Try to get that guy out of off of there, and we'll see. I bet this guy's stuck on there too. Fucking bastards. All right, cool. So they should be ready to go on the other board. So this is the other board, the one with that had the short, this in-channel MOSFET. Try to get some flux out here. For some reason, this shit is totally stuck. Freaking cold. It was 50 degrees in the workshop before I turned the little heater on. So there's some flux on that one, and then we're going to go ahead and just throw some on there so it can start to solder, to start to kind of break down. So we're going to grab our MOSFET here. Our trusty dusty tweezers. Try to turn it around. Yeah, and they usually don't like to cooperate because they're so small and don't weigh nothing.